In this question, we will try to identify the correct vertical component of velocity versus time graph and acceleration time graph for this projectile, in which you see that a ball which is thrown at a certain angle, which is also given in the question, that is theta 0, right? And it is thrown with this instantaneous velocity v0 at this angle. So what will be its trajectory? So first of all, dear students, its trajectory will be parabolic. And how it will go, let's assume that. So first of all, I show you the ball at the different positions. This is the maximum height, and then at this point, and then just before hitting the ground. So why it is moving like this? First of all, remember that this is a projectile motion which is free fall two-dimensional motion. And when I say the free fall motion, then it means that the only force exerted on the object is the force of gravity. So the net force is the force of gravity, and because we assume there is a no involvement of air resistance, air opposition, so it is, that's why this is a resultant force, and that will produce what acceleration? So that will produce the net force divided by mass, and that is equals to negative mg, because this force is downward. So acceleration due to this is equals to negative g, which means that it is a constant. If this projectile motion is occurring close to the surface of earth, then this acceleration will remain constant downward at all the points. Even at a highest position, this acceleration is negative g. That is why, dear students, if I draw acceleration time graph, then it must be a horizontal line on the graph below the x-axis, and that represents the negative g, which is negative 9.81 meter per second square for earth. Okay, so this is a graph. Now let's come to the second graph, that is a velocity time graph. And for this, let's talk about the components. Let's resolve the vector v into its components. So this is a vertical component, due to which this vertical component is responsible to take the ball vertically up, and horizontal component is responsible to take the ball horizontally. Okay, so how this vertical component is varying as the ball is moving up vertically, more and more up. So this component is decreasing, and ultimately at this point, at a maximum height, it is 0 meter per second, but still the ball will keep moving because of this component of motion v0 cos theta 0. So it means that at the maximum height, this vertical component will be maximum. And even we see the same thing, same concept, when we apply the equation vy is equals to vy0 initial velocity plus acceleration along the y-axis times t. So if you apply this, let's make this our final position, and this is our initial, this will be always our initial position, but I assume that this is a final position just for the sake of argument right now. And if I put the value here, this is 0 is equals to v0 sine theta 0 minus gt. All right, and you can see that gt is equals to v0 sine theta 0, which means that, so dear students, if I draw the velocity time graph, then notice one thing. First of all, we have the two evidences. The first evidence, we know that the slope of vertical velocity time graph is equals to acceleration due to gravity, that is negative g. So if acceleration is constant, and if it is negative value, it means that the velocity time graph must be kind of this line that should give us a negative slope. And secondly, I have properly shown you that in the very beginning, the velocity is maximum, which is v0 sine theta 0, and then it is decreasing. And at what point it will become 0? It is the time when it will reach the maximum height. And after that, now what will happen? After that, now the same vertical velocity will start increasing, but in the negative direction, and just before hitting the ground it will be maximum value. And that's why I will keep continuing this graph in the same, like this. So it means that our right answer must be the option D.